This Performance 3 recommendation finally closes the loop between the compressor and the nozzle orifice, which has driven so many of our previous insights. The maximize your flow and pressure strategy is ready to pay off. However, there is one last component that threatens all of the good work we've done so far, your nozzle. So in this video, we'll discuss the two most critical factors you should focus on, namely nozzle pressure and the diameter of the orifice. Our golden rule of thumb is that industrial blasting should strive for a minimum 100 psi at the nozzle, regardless of the size of the nozzle, because this is going to impart maximum velocity to the abrasive particles. This chart shows the necessary CFM required to achieve 100 psi based on nozzle size. 100 psi is considered optimum efficiency for sandblasting. Comparatively, every 1 psi below 100 psi equates to a 1.5% loss of blasting efficiency, while every 1 psi above 100 psi is a relative 1.5 efficiency boost. It is apparent from the chart that nozzle size, think diameter of the orifice, has a direct bearing on the CFM required to deliver the pressure we've worked so strategically to preserve for utilization. So it might shock you how much productivity and profit are simply wasted because the blaster clocks into work with a worn nozzle. Consider this scenario. Your blaster is working with a number 7 7/16 inch nozzle. This is a very common size used on many industrial job sites. Now let's pretend you have heeded our advice and optimized flow and pressure along your entire blast system to experience the transformational productivity boost we've been promising. However, because the number 7 nozzle is worn, its orifice is no longer 7/16 inch, but larger. As you can see in the chart, if your number 7 has worn its way up to a number 8 orifice, you would need 100 CFM more than expected to produce the 100 psi. But let's say you only accounted for needing 312 CFM, and you've preserved it brilliantly over the system to best optimize your compressor costs. With a worn number 7 orifice now at a number 8 orifice size and having only 312 CFM available, you just dropped your efficiency to 64%. You'll be blasting at 70 psi, wasting abrasive, labor, diesel, pretty much all your valuable resources, simply because someone chose to avoid paying the cost of a new nozzle. And we won't even discuss the lost velocity your abrasive experiences because the nozzle's venturi is also worn and compromised. Suffice it to say that even though a worn nozzle seems so insignificant, it can devastate your productivity and profitability. We hope it's becoming clear how each and every link in your system's chain could be the weak link that destroys your profits. The size of your compressor is directly tied to the size of your nozzle orifice, and all the airflow and pressure that escapes your system along the route will affect this chart, and thus your efficiency. But our cautionary tale about worn nozzles isn't the end to this Performance 3 insight. Once you understand the relationship in the chart, you can manipulate these two variables to skyrocket your efficiency. Step 1 is realizing that although each nozzle, given proper CFM, can achieve 100 psi, 100% efficiency, that doesn't mean each nozzle produces the same output. The larger the nozzle, the larger the blast pattern, and therefore the more work can be completed in the same amount of time. So on big jobs, with acres of steel to clean, the larger the nozzle, the faster the work can be accomplished. And toward this end, there are only two limiting factors: CFM and operator comfort. A larger nozzle obviously requires more CFM to produce 100 psi. This is accomplished by increasing compressor size. Yes, it will cost more in diesel to operate, but in many instances, the savings and labor cost will significantly outweigh the increased diesel cost. The larger the nozzle, the more difficult it is to manage that nozzle for hours at a time. The back thrust force causes fatigue, and blasters experience this fatigue more so at the end of each day and towards the end of each week, which makes perfect sense. A larger nozzle creates more back thrust and will therefore tire your blaster out sooner. And this balancing act between optimal nozzle size and operator comfort seemed to find its maximum sweet spot with number 7 and number 8 nozzles, until very recently. In 2021, after years of research and development, Blast One introduced the SnakeBite nozzles to the global market. This is the SnakeBite Strike. It's a number 10 blast nozzle. A number 10 blast nozzle nearly doubles a number 7 in production, but the Strike's special design reduces kickback thrust by 50%, making it feel like a number 7. Sound is also reduced by 16 decibels, making it 75% quieter than standard production nozzles. Now, referring to our chart, it does require your compressor to deliver at least 750 CFM per nozzle, but the SnakeBite Strike will double your number 7 production and blast 54% more surface area than a number 8 hyper nozzle. Imagine achieving 54 to 100% increase in your productivity simply by replacing your high production nozzles with a SnakeBite Strike. Again, many small improvements building upon one another leads to an amazing final outcome. And yet the reason contractors don't focus on these small improvements is because they wrongly conclude small improvements lead to small gains. And they wrongly conclude it's not worth the money. Now that's a big tactical mistake and opens the door for you to gain an unfair advantage in your market.
If you're ever doing a brush blast, then you need to think about using the SnakeBite Strike. SnakeBite Strike is your very big blast pattern. It's actually a number 10, which normally is too much thrust for a normal guy to hang on to, but the SnakeBite Strike with the silencer reduces the thrust, so anybody could hold on to it. We had a customer doing a spot and whip or sweep on a ship, and he used the SnakeBite Strike and was getting 1,200 square foot per hour because of how large the blast pattern was. They could stand back and with a very large blast pattern and take off that first layer of coating and any loose contaminants that they needed to remove with their whip blast.
Next up, let's optimize management.